A very good morning to everyone. Welcome in the class. Let's crack CSIR UGC NET together, and that is the name of our channel. Let's crack CSIR UGC NET. You're watching this video under the platform of Unacademy, that is India's largest learning platform. Before beginning with the class, let us have a small introduction about myself and Unacademy. I'm your educator Farida Johar Bandukwala, and I have a teaching experience of 10 years. I've qualified MP NET Examination in year 2018. If you're opting for Unacademy, what all things you are going to get? You're going to get daily life classes so that you will be always in that momentum of studies. Then you will be getting the live tests and quizzes so that you can evaluate yourself that how much you have learned so far. Then the whole syllabus is quite structured so that you can complete the whole thing in a given span of time. And there will be unlimited access towards all the videos which have been recorded in that particular category. Unacademy conducts free classes on two platforms, that is YouTube. Presently you are watching a free live class on YouTube. So just for watching the YouTube free live class, you can subscribe the channel. You can go to the channel and watch the live class. And for attending other type of free live class, that is called as special classes, you need to download the Unacademy Learning app. After downloading Unacademy Learning app, you need to make your account. After making your account, you will be asked to fill the referral code. So fill my referral code, that is FB01. When you will fill my referral code, you will be getting the access to attend the special classes of mine as well as other educators. Then there is a plus subscription. This plus subscription is a paid subscription. But by opting for the plus subscription, you will be able to complete all the 13 units in a well systematic manner because each and every topic is very nicely described in the plus subscription. And for all the upcoming classes, crash courses, short-term courses are conducted on the plus platform, which can be very much beneficial for you people. Recently, a major discount is going on in the plus subscription. For 12 months, it is costing 11,550 rupees, and for 24 months, it is going to cost you 16,800 rupees. Other than that, if you're using my referral code, you'll be getting a 10% discount. So do not forget to use my referral code, that is FB01. So for 12 months, it is going to cost you 10,395, and for 24 months, it is going to cost you 15,120 rupees. So do not forget to avail this discount and do not forget to use my referral code, that is FB01, for getting an additional 10% discount. Now let us move with the topic of today, that is Fluocytometry. That is the topic. Now, if we are talking about Fluocytometry, we should know the definition. So Fluocytometry is a measuring property of a cell as they flow in a fluid suspension across an illuminated path. We are going to talk about the whole technique in quite detail, so do not worry at all. So Fluocytometry is measuring properties of cell as they flow in a fluid suspension across an illuminated path. So what happens if there is a path of light and some particles move in the path of light? It is going to obstruct the light. So that is what the concept is over here, that if cells are passing through this path of light, it is going to obstruct the light, and it is called as Fluocytometry to measure the properties of cell, right? So let us have a look at the basic mechanism of this process. Basic mechanism. So what happens in the basic mechanism? What happens in basic mechanism, we'll need a biological sample which has to be measured. So biological sample. Then this biological sample would be labeled with a fluorescent marker. labeled with the fluorescent, sorry for the disturbance in the background, labeled with a fluorescent marker. Then cells move in a linear stream through a focused light source. Cells move in a linear stream through a focused source. That is the laser beam. I told you that some obstruction would be there. So cells are going to move in a linear stream through a beam. So fluorescent molecules get activated when light falls on them and they emit light, and that is filtered and detected by the sensitive light detectors, usually a photomultiplier tube kind of thing. So that is that at that place they are going to tell us that what is the property of cell and how many cells are there and all those things. So fluorescent molecule gets activated and emit light that is filtered, that is filtered and detected by sensitive light detectors. By sensitive light detectors. And these sensitive light detectors are nothing but photomultiplier tube. Photomultiplier tube. So conversion of analog fluorescence signals to the digital signal, that is what is happening over here. Conversion of analog fluorescent signals to digital signals. This is the basic mechanism. Excuse me. Can you please shut the door? Now let us talk a little bit more about flow cytometry. Flow cytometry. So this method allows the quantitative as well as qualitative analysis. So write over here quantitative and qualitative analysis of several properties of cells population from virtually any type of fresh unfixed tissue or body fluid. So quantitative and qualitative analysis of various of properties of cell population. Then the properties measured include particle size, relative granularity, internal complexity, relative fluorescence intensity, all these things. So what properties can be measured? That is particle related size, relative granularity, internal complexity, and relative fluorescence intensity. And relative fluorescence intensity. These properties are done with the help of flow cytometry. Now, the most commonly analyzed material in flow cytometry that we should see, commonly analyzed material. So, they are blood, bone marrow aspirates, bone marrow aspirates, then lymph node suspensions. Lymph node suspensions. So these are in terms of medical field, that usually flow cytometry is done for blood, bone marrow aspirate and lymph node suspensions. Now we have seen that for what it is done, what all things can be done, and what is the basic idea or the procedure, basic mechanism of flow cytometry. So we are quite acquainted with the idea. Now we should move towards the principle of flow cytometry, that how all things occur. So let us move with the principle of flow cytometry. Principle of flow cytometry. So flow cytometer is actually composed of three main components. So first is the flow system. Flow system is also called as fluidics. So cells in the suspension are brought in single file passed. Then the second component is the optical system. The optical system, that is light sensing. Light sensing. So a focused laser which scatter light and emit fluorescence, that is filtered and collected. Then the electronic system. The electronic system, that is also called as signal processing. Signal. So emitted light is converted to digitized value that is stored in file for analysis. So these three are the major components of flow cytometry. We'll be dealing with each and every system in detail. So the first system that we need to talk is the flow system. The flow system. So one of the fundamentals of flow cytometry is the ability to measure the property of individual particle, and that is managed by the fluidic system. So when a sample is injected in flow cytometer, it is ordered into a stream of single particles. So we would write this: when a sample is injected into flow cytometer, it is subjected into single particle stream. So fluidic system actually consists of a flow cell. And this is actually made up of quartz chamber. So there are two things, that is a central channel or core and the outer sheet. Central channel, oblique core and outer sheet. So in the central channel is the place from where the sample is actually injected. An outer sheet consists or contains faster fluid, that is the sheet fluid. It is usually 0.9% saline or something which is normal to the buffer, enclosing the central core. So central channel core and outer sheet. Now let us talk about the hydrodynamic focusing. Hydrodynamic focusing. So once the sample is injected into a stream of sheet fluid within the flow cytometer, they are forced into the center of the stream, forming a single file by the principle of hydrodynamic focusing. So we'll for hydrodynamic focusing, it would be much better if I would draw a picture for you. So let us draw a picture for this. Like this. But when they will enter this place, they will be in a single particle like this. So let us name this. This is the central core, and this is this place. There is actually, it is actually like this. So this is the sheath fluid, and this is the single flow. Most important thing, we'll write it with another name so it pops up. Single flow. This is the hydrodynamic focusing. Only one cell or particle can pass through the laser beam at a given moment. We'll write over here. Only one cell or particle can pass through the laser beam at a given moment. At a given moment. So that is the hydrodynamic focusing. So the sample pressure is always higher than the sheet fluid. We'll write over here, sample pressure is always greater than the sheet fluid pressure. Sheet fluid pressure. And this ensures a high flow rate, allowing more of the cells to enter the stream at a given moment. Now, there are two things that you need to know, that is high flow rate and low flow rate, for which like at two different rates it is done. So first is high flow rate and low flow rate. So for high flow rate, what all things are analyzed? That is immunophenotypic analysis of cells. Immunophenotyping analysis of cells. And for low flow rate, what all things can be analyzed? DNA analysis is done at low flow rate. Right. Now we'll be talking about the optics of the system. Optics. So after the cell delivery system, the need is to excite the cells using the light source, as it has been already labeled with the fluorescent dye. So the light source which is used in fluocytometry are of two types, that is laser and arc lamps. So optics is made up of two types, laser or arc lamp. More commonly, laser is used. So while lasers are actually more common, they are actually highly coherent and uniform. They can be easily focused on a very small area like sample stream. Then they are monochromatic, emitting single wavelength of light. These are some of the benefits of using laser. So they are highly coherent and uniform. Highly coherent and uniform, easily focused on a very small area. Then they are monochromatic. that is, they are going to emit a single wavelength of light. And when we are saying arc lamps, so what kind of arc lamps are used? They are actually less common to be used, and in laser, argon lasers are mostly used. So argon lasers, and argon lasers, they emit the wavelength at 488 nanometer of wavelength. So that is blue to blue green, blue to blue green. So this is the optics. Optics does not end over here. There are various sides of optics. So we'll be talking about that. So when a light intersects a laser beam at the so-called interrogation point, two type of events occur. That is light scattering and emission of light. So we'll be seeing that. Excuse me. When a light intersects a laser beam at so-called interrogation point, two events occurs. Two events occur. And what are these two events? One is light scattering, and second event is emission of light. Emission of light. So this emission of light occurs because of the fluorescence, and light scattering occurs because of its particulate nature. So this is because of the fluorescence. So that's why it is also called as fluocytometry, Fluo, because of the fluorescence. So fluorescence is the light emitted during the decay of the excited electron to its basal state. That we already know the chemistry behind it, right? So we are not going into that. Now we'll be talking about the optics further, that is the light scatter, and then we'll be talking about the other things which are related to that, that is the emission of fluorescence light scattering and emission of fluorescence light. These two would be our focus further. So just give me a second. So first is light scatter. So when light from a laser interrogates a cell, the cell scatters light in all the direction. The scattered light can travel from interrogation point down to the path of detector. So how does this happen? We'll draw a picture for this so that we can get a much clear idea. This is the light coming. There will be a screen over here, and this is the apparatus, the fluocytometer, and these are the cells. We are drawing the cells now. These are the cells which are moving in a single row. And when the light falls on it is going to emit light in various directions. So we are going to draw the light now. The light would be emitted like this. So this is how the light scatters. The first thing. After that, we need to know about the emission fluorescence light. That is the fluorescence. So first is light scatter. Second is emission of fluorescent light. Emission of fluorescent light. This is also called as fluorescence. So as the fluorescent molecule present in or on the particle is interrogated by the laser light, it will absorb some of the energy from the laser light and release the absorbed energy at a longer wavelength. So emitted photons, they pass through the collection of lens and are split and stirred down into this specific channel with the use of filters. And this is how the emission of fluorescent light occurs. That is, we'll write that fluorescent molecule absorbs light, and after that it is going to go to the higher level from the ground level, excited level, and then it is going to release absorbed energy at longer wavelength, at longer wavelength. So these are the two things. Now in optics we need to know about the filters, right? That what kind of filters would be used. So in the next point, in the optics only, we'll be talking about filters. Optics, filters. So different wavelengths of light are scattered simultaneously from a cell. Various different types of wavelength can be scattered. Different wavelengths of light are scattered simultaneously from a cell. So there is a need to split the light into its specific wavelength in order to measure the quantity of them independently, and this thing is done by filters. So the system of filters ensure that each of the photodetector receives the light band of various wavelength, right? So the system of filters ensure that each photodetector receives light bands of various wavelengths. So the optical filters are designed in such a way that they absorb or reflect some of the wavelength of light while transmitting the others. So there are actually various type of filters which are used. So the types of filters, so they are long pass, they are short pass, then they are band pass, and they are dichroic. So these are some of the filters. Now filters, for long pass filters, for short pass filters, and for band filters and dichroic filters, there are specific things. So I think it would be better if we discuss each and every one in a separate way. So long pass filters, what happens in this? Transmit all the wavelength greater than a specified wavelength. Transmit all wavelength greater than specified wavelength. This is the long pass filter. After that, short pass filter. Short pass filter. So transmits all the wavelength less than specified wavelength. So transmit all wavelength shorter or lesser than specified wavelength. After that, band pass filter. So transmits a specific band of wavelength. Transmit a specific band of wavelengths. After that, dichoric filters. So long pass or short pass filters, they can be long or short pass filter. They are placed at an angle of 45 degree. Placed at 45-degree angle. So part of light is reflected at 90 degree and part of light is transmitted and continued. Now we need to know about the detectors, we need to know about the electronics, and then we need to know about the data analysis, that is the plot and gating and interpretation of the graph. So these all things we need to do, and we need to know that what is so unique in flow cytometry and what are the uses of flow cytometry. So I was just telling you so that be mentally prepared that what all things we need to do. So detectors, what about the detectors? So before moving with the detectors, just give me a second. Hello. So we were talking about optic detectors. That was the thing that we have to talk. Actually, we have to add the slides. So let us just add the slides for continuing. So detectors, that too optic detectors. So the photodetectors, they convert the photons to electrical impulse. So their use is to convert photons to electrical impulse. Right. So the two common types of detectors which are used in flow cytometry are photodiode and photomultiplier tube. Photodiode are used for strong signals when saturation is a potential problem, example forward scatter detector. And photomultiplier tubes are more sensitive than photodiode, but it can be destroyed easily by exposure to too much light. So used for the side scatter and fluorescent signals. So photomultiplier tube is more sensitive but can be destroyed easily. So both have their own advantage and disadvantages. Now after detectors, we need to talk about the electronics. So the electronic subsystem converts photo to photoelectrons. It measures the amplitude, area and width of the photoelectron pulse, and the pulse is amplified linearly or logarithmically, and then it is digitalized so that it can be calculated. So electronic system is actually used to convert photons to photoelectrons, and it is used to measure amplitude, area and width of photoelectron pulse. Then it amplifies the pulse linearly or logarithmically. Amplifies the pulse. So this is the electronics. Now the data analysis is done through single color histogram, two color dot plot, two color contour plot, two color density plot and various other things. So data analysis is done through gating, and interpretation is also done with the help of that. So now coming to the what is unique in flow cytometry, because interpretation part is like not that which is asked in the examination. Mostly the basics that we have done, that is asked. So what is unique in flow cytometry, that we need to see. What is unique in flow cytometry? So it is multi-parametric, then rapid analysis of large number of cells is done. So rapid analysis of large number of cells. Information of a single cell can be obtained. Then detection of rare cell population can also be done. Then it allows physical isolation of cells of interest. Allows physical isolation of cells of interest. So this is what is unique of flow cytometry as compared to any other technique. Now talking about the uses of flow cytometry in terms of its application and then clinical application. Two ways we'll be talking. So applications and clinical applications. So first of all, applications. So first is analysis. Analysis in terms of immunophenotyping. Immunophenotyping. Then dyes that bind to nucleic acids. Nucleic acid like DNA and RNA. So DNA and RNA, and then functional assays. Functional assays. After analysis, it is used for cell counting as well. After cell counting, it is also used for cell sorting. So these are some of the normal applications. Now coming to the clinical applications of flow cytometry. So it is done for detection of HIV/AIDS. So that is done through absolute counting of CD4. Absolute CD4 counts. Then for joint pain also it is done. Joint pain. So that is HLA-B27 assay. Then hematological malignancies. Then solid tumors, it can also be detected with the help of the flow cytometry. Then primary immunodeficiency disorders. Then in clinical application, so we'll just write 1, 2, 3, 4, 5. So it can also detect hemolytic anemia by reticulocyte count, osmotic fragility assays, various things. So hemolytic anemia. Then fetal hemoglobin detection. fetal hemoglobin detection, then bleeding disorders, then transfusion and transplantation, in those things also help of flow cytometry is taken, like residual WBC count and leukodepleted blood plaques is done. Then host immune response in sepsis. So flow cytometry is used in cytokine response as well. So host immune response in sepsis. This also is the clinical application of flow cytometry. So these are some of the things that we need to know whenever we are talking about flow cytometry. These all things cannot be at all skipped. Their clinical applications and their applications and their detectors and everything. These all things need to be read. So I think we have completed this topic. Like we have covered almost all the things that are necessary. So flow cytometry is a method for measuring the properties of cells. So we'll just highlight the word measuring the properties of cells as they flow in a fluid suspension across an illuminated light path. Then basic mechanism, we have seen that we need a sample, then it should be labeled with fluorescent marker, then the cells, they are going to move in a linear stream, then light is going to fall on them, they'll get activated, then they are going to emit light, and this light is going to be detected or it is read. After that, the flow cytometry is a quantitative and qualitative analysis. Both of the thing is done with the help of flow cytometry. So the properties that are actually measured or detected with flow cytometry, that we have seen. Then we have seen that what all things are analyzed. Then principle of flow cytometry contains fluidics, light sensing and signal processing. So we have done that. The flow system we have done. Then hydrodynamic focusing we have done. Then we have seen the optics. Light scatter and emission of fluorescent light. Then optics contain various filters, long pass, short pass, band pass and dichroic filters that we have seen. Then detectors are of two types, that is photodiode and photomultiplier tube. Then in electronics, the whole signal is amplified so that it can be calculated. Then we have seen what is unique in flow cytometry, and then what we have seen is application, normal application and clinical application. Like this, we have completed our topic. We have done all the necessary things, and by this there comes the end of our lecture, and hope you people have understood the things. And as we say in the starting and end, let's crack CSIR UGC NET, and that is the name of our channel as well. If you haven't subscribed to our channel, subscribe our channel, hit the bell icon for getting all the notifications of the upcoming videos. If you really like my video, give it a thumbs up, and do not forget to use my referral code, that is FB01 for the plus subscription. By this you will be getting a 10% discount, and use my referral code FB01 even for attending the special free classes. So you can get the benefit of attending the free classes as well by using my referral code FB01. So like this comes the end of the lecture. Thank you very much. We'll be meeting again in the evening at 5 o'clock, and we'll be doing an interesting topic of GATE syllabus. So hope to see you all at 5 o'clock, and we'll be talking about the interesting topic of GATE syllabus. And this is it for now. Thank you very much. It's a bye from my side.